Hey guys, welcome to 6.1. In chapter 6, we're starting the conversation about factoring. And in 6.1, it's all about greatest common factor. Okay, so on number 1, you have two terms, and there's no operation, so we're strictly looking for GCF. And so you look at the numbers first, and then you look at the letters and say, what do I have in common? All right, so the first thing you should notice in number 1 is that they're both even. So they both have at least a 2 that you can take out of it. All right, and then but just because they're even doesn't mean that 2 is the only number that goes into it. So we check it real quick. And does anything else go into it? Like, does 4 go into it? Well, 4 goes in 20, but not 14. So we're kind of stuck there. You could keep going up and see if anything does work. But nothing else is going to work. So I'm going to have a 2 that's in common between my numbers. And then you ask yourself, they both have at least one x. How many x's do they have in common? 2. Or another way of asking it is, what's the least number of x's that you see? And that's x squared. So if I have x squared, I can pull out an x squared. If I have x to the fourth, I can take the x squared out of the x to the fourth. And so altogether, they have x squared, or 2x squared is my greatest common factor of number 1. And you can do this to you have to have at least 2, obviously, to get a greatest common factor out. But you could have a whole string of numbers as long as you want to find the greatest common factor. So like on number 2, I'm looking at 3 terms. And again, common factor, greatest common factor. So if they all your terms have to have it in order for you to be able to take it out. Okay, so on this one, they're all even again. So at least 2 goes into it. But again, you want it, just because 2 goes into it, you want to keep going and see if there's anything else you can go to it. And it turns out that 12, 8, and 20 are all multiples of 4. So I'm going to take a 4 out. Okay, and now you have y to the 6, y squared, and y. They all have at least 1. And it turns out that's all you're going to get because that last term only has 1. And so that's as far as you go. That's your greatest common factor. Okay, number 3, we're going to switch gears just a little bit. And we're not looking just for the greatest common factor, but we're looking to simplify this thing using the greatest common factor. So what does that mean? Well, what do 8 and 28 have in common? Well, 4 goes into both of them. So I can pull the 4 out. And then 28, or sorry, we already done that. They both have at least 1x. It turns out they have 2 x's in common. And then you want to open parentheses and multiply by what's left. So you ask yourself, 4 times what is 28? 7. And then if I have x squared, how many more x's do I need to get x cubed? Just 1. Okay, plus, and then 4 times what is 8? Well, that's 2. And then I already have the x squared, so that's good. So the whole idea here is you want to write this original expression as a term of factors. So what times what gives you this? And using the greatest common factor, this is how we write it. We take out everything that they both terms or all terms have in common, stick it out front, and then open parentheses, multiply by everything that's left. And the idea is that if you multiply these things back out, you get your original. So if I multiplied 4 times 7, or 4x squared times 7x, you get 28x cubed. If you say 4x squared times 2, you get 8x. And so I get my original back, and that's the whole idea. Okay, on number 4, again, just take it one step at a time. Look at your numbers. 6 and 54, what goes into it? Well, 6. And then 4y to the 4th, 4y to the, or y to the 4th, y to the 6th. Says I can pull the y to the 4th out. Now, this is interesting because 6y to the 4th is my first term, but it's also my greatest common factor. So if I'm taking that common factor out, I have to replace it with something because I'm not just getting rid of it. All right, I'm not going to have just one term on the inside. I'm going to have 2. All right, so you remember, ask yourself, what times 6y to the 4th times what is 6y to the 4th? Well, anything times 1 is itself. And so anytime one of your terms is the greatest common factor, you're going to replace it with 1. So 1 plus, right, 6 goes into 54 9 times. And then how many more y's do I need? 2. Again, you should be able to multiply this back out to get your original, which is another reason why I put a 1 there. Because I started with 2 terms. And if I multiply it back, I should still end up with 2 terms. Okay, number 5. Again, you had 3 terms, but it's the same process. Right? Look at each term, start with the numbers. I can take a 6 out, because 6 is in 42 and 18. Right? But unfortunately, because 18 doesn't have a y, I can't take out a y. So this is going to be y squared minus 7y. Oops. Plus 3. Okay. Now, on 6, sometimes your greatest common factor isn't, it's more, sometimes your greatest common factor is a polynomial in itself. So like here, they both terms have an x plus 10. So I'm going to take the x plus 10 out, and I'm going to combine the terms that were on the outside. So I have an x and I have a plus 8, and I'm just going to bring those down right here. And that's that. It's really that simple. Okay, so again, looking back at number 4, see, we have an x plus y in both terms. I'm going to bring that out front. That's going to leave me with 9x and minus, remember, when the greatest common factor is one of my terms, I replace that term with a 1. So x plus y times 9x minus 1. That will be my answer. Okay, number 8, I have 4 terms. And anytime you have 4 terms, you're going to do what they call factor by grouping, which is essentially taking the greatest common factor twice. Okay, so here's what I'm talking about. So I'm going to take the first 2 terms, group them like so. The second 2 terms, group them like so. Okay, and then I'm going to take the GCF out of the first parentheses. All right, that's going to be x, and I'll be left with x plus 7. And then on the second parentheses, I can take a 3 out, a positive 3. So I'm going to say plus 3, and that's going to leave me with an x plus 7. Now, you need the parentheses here to be the same. Otherwise, you can't take the second greatest common factor out and finish the problem. So if you don't get the same parentheses, you've done something wrong. So here's, so that's what we're doing. So I'm going to take the x plus 7 out, and I'm going to write it, clean it up, and say x plus 3. Okay, so that is my answer. I'm going to do the same thing on number 9. I'm going to group the first 2, and group the second 2. Now the first 2 I can take out an x squared. It's going to leave me with x minus 3. And then I'm going to take out a positive 6, so plus 6. And that's going to leave me with x minus 3. Again, you want that parentheses to be the same. Otherwise, something went wrong. Okay, so you have x squared, x minus 3 times x squared plus 6. Okay, last one. Again, number 10 is just an application type problem. It's the same concept applied to a figure. Okay, so if we have, this is essentially asking you 9x squared times what equals 9x to the 5th minus 45x squared. So you're trying to figure out what you multiplied by to get 9x to the 5th minus 45x squared. Okay, and I know this because area of a rectangle is base times height. And so I can multiply these 2 out and get my area. But this time they gave me the area in one of my dimensions. So that's, you have to figure out that what else you need. Okay, so 9, you already have a 9. Okay, so how many more x's do you need to get that first term? So 9x squared times what is x, 9x to the 5th? Well, that's just going to be x cubed. Okay, and then 9x squared times what is negative 45x squared? Well, take it a piece at a time if you need to. 9 times negative 5 is negative 45. All right, and then I already have the x squared, so I don't need to multiply anything by that. And so there it is. The x cubed minus 5 is my answer. Okay. And that's 6.1. Hope you got it. Hope you enjoyed it. Good luck on your homework. I'll see you in 6.2.